Hello, and today we're going to learn a little bit about galvanic cells, or voltaic cells, or sometimes they're even called electrochemical cells. Now, in an electrochemical cell, or a galvanic cell, let's go ahead and draw one up. First thing we'll need to do is we need to put in some electrodes. We normally put this in a beaker or something to contain some liquids. Then we'll place in this case, some zinc sulfate, or 1 molar zinc sulfate, and 1 molar copper sulfate. You'll attach your two electrodes with a wire. Normally we'll put in some sort of device. In this case, we'll have a voltmeter. And then lastly, you need to make sure you have a salt bridge. All right, something to allow ions to travel back and forth. So when we're looking at this galvanic cell, there's a couple things that are going to occur. So on the left side here, we're going to undergo a reaction where we have zinc solid breaking up into zinc 2 plus and 2 electrons. Now, for this, we'll see that we actually have oxidation occurring. And because of this is normally referred to as the anode. So wherever the anode is where oxidation is occurring, and this is where we're going to be producing our electrons. So as this zinc is breaking down into zinc 2 plus, it also forms electrons. And these electrons are going to flow through this wire across our device and then through our electrode here, and in this case it's going to interact with our copper 2 plus. So on our right side of the reaction, or cell, we have copper 2 plus 2 electrons forming copper solid. Now, how do we figure out that this is actually copper 2 plus? Well, we have copper sulfate. And for copper sulfate, we can simply look at the oxidation numbers. So you may recognize SO4 as being a polyatomic ion, and that polyatomic ion has a -2 charge overall. And since copper sulfate is overall neutral, we know that our copper is going to have an oxidation number of +2. Now when we break this up into ions, we'll have an SO4 2- ion floating around in our solution, aqueous. And we're going to have copper 2 plus, and this 2 plus is simply coming from the oxidation number. Alright, so electrons are going to be flowing from our zinc as it breaks down into forming zinc 2 plus. Electrons flow through our device, down through our electrode here, and interact with our copper 2 plus to form copper solid. Now, this electrode, where the reduction is happening, this interface here, where we're actually just now interacting with the copper 2 plus ion, whatever electrode is here, this is considered to be the cathode. It's where reduction occurs. Now, there's a couple ways to try to remember this. I grew up in Texas, and there, air conditioners were very important. And we normally refer to those as ACs. So if you're following the path of the electrons, it's going to spell out A for anode and C for cathode. So it'll always spell AC if you follow the path of the electrons. Another way you could remember this is that anode is starting with a vowel and oxidation starts with a vowel. This is always true. The anode is always where oxidation occurs, and the cathode starts with a consonant, and reduction starts with a consonant. And this is always true as well, where we always have a cathode is where reduction occurs. So to break this down a little bit more, basically what is going on is at the anode, we're going to have zinc 2 plus being produced. So our solid zinc is going to turn into zinc 2 plus, aqueous, and what's going to occur is we are going to start to have that solid slowly disappear. It will corrode. So as this starts to corrode, and all corrosion is just meaning that it's essentially turning into another form, normally into some form of ions, and our metal will slowly disappear. That is corrosion. So as that occurs, we're producing electrons, and then over on the copper side, we're going to be having copper produced. So at the cathode, copper solid is produced, and as that is happening, it is going to plate onto our electrode. So copper solid will plate on our cathode. In this case, copper. So to kind of reiterate that, at our anode, our zinc electrode is being corroded, and at our cathode, the copper solid is plating onto the copper electrode. So essentially it will get bigger. Now another thing has to occur here, otherwise our voltaic cell will not work, and this is the salt bridge. So at the salt bridge, we have here that we have NaCl, sodium chloride. And so we're going to have some sodium plus ions and chlorine minus ions. And basically, what's going to happen is these are going to be used to counterbalance the ions we're producing from our zinc and copper. So the chlorine anions from our salt bridge are going to flow. They're going to flow into our zinc sulfate solution, and this is mainly to counterbalance that zinc 2 plus that's being produced. We need to keep it overall neutral. And so to do that, since we're making these positive zinc 2 plus cations, we need an anion, such as chlorine minus, to counterbalance that. On the other end, we have our sodium plus, and it's going to have to come down into our copper sulfate solution. And main reason for that is our copper sulfate, our copper 2 plus is essentially going away because it's becoming solid. It's being plated as copper solid. And so our cation, the sodium plus and the salt bridge, will flow into the copper sulfate solution to keep it electrically neutral as copper 2 plus is being consumed, or as it's being plated onto the copper electrode. All right. Now, one way to kind of help remember these definitions here for cations and anions is there's two ways that I know of. If you look at the cation, you'll notice that it has a T here, and the T looks a little bit like a positive sign. So cations are always positive. They're the ones that look like they have a positive sign when you spell out the name. Another way you can kind of remember it is it spells out the word cat. And so one way you can kind of remember that is cations are positive. Alright, because cats have paws. So hopefully that'll help you keep some of this stuff straight. We'll go through a couple of examples of this and see how this works. For now, you probably don't know how to figure out where the electrons are coming from, but we will get to that eventually. But this is a general breakdown of a galvanic cell or a voltaic cell. So thank you, I hope you enjoyed it, and I look forward to seeing you in the next video.